Have you ever wondered how scientists identify different compounds in a mixture? The answer lies in a concept known as retention time. Picture yourself in a race. You and your competitors each have different abilities, so naturally, some of you will finish the race faster than others. This is similar to what happens in a process called chromatography, a technique used in analytical chemistry to separate and identify different compounds in a mixture. In a chromatography system, each compound is like a runner in a race. The start line is the point of injection, and the finish line is the detector. The time it takes for a compound to get from the start to the finish line is what we call the retention time. Just as every runner has a unique pace, each compound has a unique retention time, depending on how it interacts with the race track. In this case, the stationary phase in the chromatography column. Some compounds race through quickly while others take their time. Consider two compounds, A and B. If compound A has a retention time of 10 minutes and compound B has a retention time of 15 minutes, it means that compound B takes longer to travel through the column and reach the detector compared to compound A. Retention time is more than just a race, though. It's a powerful tool to identify and quantify the compounds in a sample. By analyzing the retention times, scientists can tell which compounds are present in a mixture and in what quantities. To recap, retention time is the time it takes for a compound to travel through a chromatography system from the point of injection to the detector. It's a key parameter in analytical chemistry, used to identify and analyze different compounds based on their unique retention times. It's like a race where each compound's finish time helps scientists determine its identity. The slower ones aren't necessarily losers. They're just taking their time interacting with the stationary phase. So next time you hear about retention time, think of it as a race among compounds, each with its own unique pace. Remember, in the world of analytical chemistry, every second counts, and that's the beauty of retention time. It's a brilliant example of how time in the hands of scientists becomes a tool for discovery and understanding.